2 research groups this month have independently discovered a new planet around the star Beta Pictoris, 63 light years away. Yang and collaborators discovered 31 distant quasars, including not one, but 2 quasars that have broken the record for the most distant quasars ever found. Every reason they give already has an existing solution that doesn't require a giant mirror in space. Add to that the fact that it's the same night as the sunset eclipse, and I just don't think there's a better night this year to take a picnic out somewhere in the countryside and just enjoy the wonders of the night sky together. Welcome back to Night Sky News for July 2026 with me, astrophysicist Dr Becky Smethurst. In this episode, we're chatting about 3 new exciting scientific discoveries, from a new planet spotted by JWST around the star Beta Pictoris to the most distant quasar ever found, spotted by Euclid, and the first missing black hole found in a star cluster in the Milky Way by Hubble. And of course, we'll also chat about how you can watch the total solar eclipse and the Perseids Meteor Shower, which are both coming up on Wednesday the 12th of August. There's chapter markers down here if you want to skip ahead to any of those specific news stories, plus any scientific research papers I mentioned are all going to be linked in the video description down below, free to read. But before we get to the latest space news, as always, let's kick things off with a quick look at what you can see in the night sky this month, which I filmed on my recent trip to Flamsteed Observatory in Derbyshire. And let's start by looking up. Alright, we got lots to look out for in the night sky in the next couple of weeks, including a solar eclipse, the Perseids Meteor Shower, and Saturn glowing bright in our evening skies. So let's start with the eclipse on the 12th of August, where the moon will pass between the sun and earth, and for a lucky few along the path shown here by that dark red line, the moon will fully block the sun for a few minutes in a total solar eclipse. Here in the UK, we're going to see a partial eclipse. Just after 7 o'clock is when anywhere from about 90 to 96% of the sun will be covered by the moon. So it won't get that dark for us here in the UK, sadly, but you'll notice the reactions of like plant life and animals. Now remember, if you want to watch the eclipse, never look directly at the sun. You will damage your eyes. Instead, the best thing to do is to project the image of the eclipse down onto the ground or on a piece of paper. So you use anything with holes to do this. My favorite way is to use a colander because you just get multiple images of the eclipse projected this way. But you can also make a pinhole camera with a cereal box too. I'll pop some links in the video description down below on how to do this. The other way to watch the eclipse is to use some of these eclipse glasses. Now you might have some of these buried in a junk drawer somewhere from the last eclipse. If that is you, please make sure to check them for scratches before you look at the sun with them. Hold them up like to the big light in your house with the big light switched on and just check that there's no light getting through them before you then look at the sun with them. These are brand new though. They were sent to me by the Fin Whale Eclipse project, which is a really fun project because the path of this eclipse is actually sort of mirroring the migration patterns of fin whales in the Atlantic Ocean. So I love the connection there between astronomy and marine biology. I'll pop some links in the description below about safe eclipse viewing, including a link to ukeclipse.com, which has collated information on eclipse watching events happening across the UK. Now, once you've watched the eclipse and the sunset that night on the 12th of August, don't go back inside just yet, because the middle of August can only mean one thing when it comes to astronomy, and that is the best meteor shower of the year, the Perseids Meteor Shower, which is visible wherever you are in the world. Plus, we're going to have perfect conditions for watching the Perseids this year because the sky will be nice and dark because we will have a new moon because we've had an eclipse earlier that same day. Now, the best thing about meteor showers is you do not need any equipment to watch them. No binoculars, no telescopes. You just need to give your eyes time to adjust to the darkness. Can get a little bit uncomfortable, like craning your neck directly up though, so I'd always recommend lying down to watch a meteor shower. The shower will be active from the 17th of July to the 24th of August, but the peak on the 12th is when the most meteors will shoot across the sky. It's hard to predict just how many meteors there are going to be, but in the darkest of skies, away from light pollution, there could be anywhere from 100 to up to 150 meteors per hour. That's around 2 shooting stars per minute. But remember, the closer you are into a city, the more light pollution there'll be, which will wash out a lot of the fainter meteors, which means you're not going to see as many. So if you can get somewhere darker, whether that is just in the middle of a park in the city or out to the suburbs or even out to the countryside, then I'd highly recommend it on the night of the 12th of August. It will be well worth your time. The Perseids are caused by tiny lumps of rock left behind by the comet Swift-Tuttle on its 133-year orbit around the sun. Earth passes through this rubble every year in August, and we see those those lumps of rock burn up in the atmosphere as shooting stars. Shooting stars, though, are really quick as they streak across the sky, so if you blink or happen to be looking in the wrong direction, you're going to miss one. So I always say that meteor showers is a really fun activity to do with friends and family. Like, the more people you've got around you, the more meteors that you will spot together. And to top it all off, the Perseids are happening at a very normal, respectable time of around about 9 o'clock. You can watch in the late summer evenings, no early get-ups or late nights required. Add to that the fact that it's the same night as the sunset eclipse, and I just don't think there's a better night this year to take a picnic out somewhere in the countryside, either as a date night or a family night or with a group of friends, and just enjoy the wonders of the night sky together. And while you're out watching the Perseids, or just while you're walking back from the pub at one evening this month, look out for Saturn rising in the east at around 11 o'clock. It will rise earlier and earlier as we get into August, so much so that by the start of September, it's going to be rising at 9 o'clock. Now, Saturn has a yellowish tinge to it that should help you pick it out from the background stars, but if you're not sure what you're looking at, I've got 2 tricks to help you out. The first trick is to know that stars twinkle and planets don't. That's because the light from stars is a tiny pinprick, so any turbulence in the Earth's atmosphere disturbs the starlight and makes them twinkle. But the reflected light from planets is coming from a much larger area because the planets are so much closer to us. So if only a tiny little bit of that starlight gets disturbed by turbulence in the atmosphere, there's more light coming from the planet overall, so it looks more solid. The second trick I then have for you is that the moon can also act as a handy signpost for where to look for Saturn. So on the night of the 3rd of August into the morning of the 4th, the just past half moon will be above Saturn, making it easier to find. That way you can learn like which window in your house or spot in your garden is the best for looking at Saturn. And you should do that astronomy homework now this month, because Saturn is only going to be getting brighter and brighter as we get into autumn, as it gets closer to lining up with Earth and the Sun at the start of October. So a big thanks to Flamsteed Observatory for having me. I was here filming with the BBC for Sky at Night, so make sure you catch me on their next episode, airing on Monday the 10th of August. Flamsteed have a great setup here, and if you want to visit for yourself, they have an open evening every second Saturday of the month for visitors in case you want to see Saturn through a telescope for the first time. I'll pop a link in the video description down below if you want to know more, but for now, let's come back down to Earth and chat about what's been happening in space news in the past month. Alright, so we're going to do the good news, the bad news, and then treat ourselves to 3 new exciting scientific discoveries. So let's start with the good news. Remember those budget cuts to astronomy and astrophysics research in the UK that were announced by the UK Research and Innovation Funding Body back in January? Those cuts were going to be anywhere from 30 to 60% due to rising facilities costs that were disproportionately affecting astrophysics research just because of how the sharing of funding was organised amongst the research body. I even went to the Houses of Parliament last month to speak to MPs about this, to raise awareness and get them to lobby against these cuts. And the good news for astronomy and astrophysics research anyway is that UKRI have announced a new 5-year strategy that prioritises funding for blue sky research, and it stops the cuts to astrophysics research that, would have been felt on the ground by people like me at my career level, where you're post-PhD but not quite a professor yet, and the money goes to funding 2, 3, 5-year positions to make jobs like this in this sector. So the entire astro community is immensely relieved at this news. It means the UK can still benefit from all the effort and money that we've put into the likes of the Rubin Observatory, which is taking an image of the sky every 3 nights to monitor what changes, just to give you one example. But it also means that because of rising energy costs, the cost of silicon because of the AI boom, and big swings in exchange rates, that savings are going to have to be made somewhere still, which are thankfully going to be spread out more across different fields, but the areas that will be biggest hit by those would be labs and facilities and big experiments. The full impact of these cost savings across the board isn't really known yet. That's going to become clearer in the next few months. So it's a victory for astrophysics research, but not really for, science across the UK anyway. So that was some good news, some bad news, but it wasn't the bad news that I've got to report, because oh no, that fresh hell came from the US this month when Reflect Orbital got approval to launch a prototype mirror satellite that is 60 feet across that from orbit could reflect sunlight back down onto the night side of Earth, allowing solar farms to continue generating electricity at night or providing illumination during emergencies. At least that's the marketing spin that they've put on this to sell it to the public anyway, but it's fair to say that us astronomers are absolutely outraged by this. Like, we already feel like the night sky is threatened by the many mega satellite constellations to provide internet from the likes of SpaceX and OneWeb, not just for the impact on our professional observations that we get with telescopes on the ground, but also because of humanity's like basic right to enjoy a dark night sky. And now Reflect Orbital want to put a 60-foot mirror into space that they claim will be capable of reflecting as much light as a full moon over a roughly 9 square mile area. And that's if you've got like a direct view of it. If you've got like a view of an angle on this big mirror up in space, it will be as bright as Venus is in the night sky, which is the brightest thing after the moon. Reflect Orbital then also wants to end up with a constellation of satellites as well, launching 50,000 of these mirrors by 2035, with 1,000 launched by the end of 2028. For context, across both like the northern hemisphere and the southern hemisphere sky, there's anywhere between like 4,000 and 9,000 stars that are visible to the human naked eye, depending on your age and how good your eyesight is, and also your location, like how close you are to the light pollution of cities. In places like London and New York, for example, it's probably more like 50 stars that are actually visible. So imagine instead 50,000 things that are as bright as Venus just drowning out all of the actual stars instead. And it's just so frustrating reading like all of the justifications for why they want to do this, because every reason they give already has an existing solution that doesn't require a giant mirror in space. In emergencies, we have headlamps and flares and big LED floodlights. For solar power at night, when demand is admittedly higher, we have battery storage. If you want to replace fossil fuels with more renewable energy, build more solar farms or put more solar panels on the roofs of houses and tower blocks, because that is a lot cheaper than developing an engineering solution to a constellation of giant space mirrors. I mean, if this goes ahead, we could be the last generation to enjoy a pristine night sky in its entirety. Not to mention the effect that these mirrors will also have on wildlife. Now, rest assured, there are many organisations opposed to this who are dedicated to fighting it, including the American Astronomical Society, the Royal Astronomical Society, and Dark Sky International. They're all in the process of evaluating the legal avenues to oppose not just the single prototype mirror that's been approved for launch this month, but also the future plans for this constellation of mirrors as well. All right, that's enough of being the bearer of bad news for this month. Let's chat about our 3 exciting new scientific discoveries and start with one from JWST, the James Webb Space Telescope, because 2 research groups this month have independently discovered a new planet around the star Beta Pictoris, 63 light years away. And that was a huge surprise because Beta Pictoris, or Beta Pic as it's known, is one of the most studied star systems in all of astrophysics. It's one of only a handful of stars with multiple planets known that also have direct images taken of the planets. So this is where you block the light from the bright star so that you can detect the much fainter light reflected off the planet. Take those images over a couple of years and you can even get a time lapse of the planet moving as well. Not only that, but Beta Pic was also the first directly imaged debris disk, so leftovers from forming the planet system, which is still one of the most actively studied debris disks today. All of this to say, we have a lot of images and we have a lot of data on Beta Pic. It is extensively studied, and yet still Sutcliffe and collaborators and Gibbs and collaborators managed to spot a brand new planet in data from JWST and the Very Large Telescope in Chile. That makes Beta Pic only the second directly imaged system with more than 2 confirmed planets after HR 8799. You can see the planet here in both the VLT imaging and the JWST data. It's very obvious in both. Just goes to show that using a more powerful instrument, the right instrument for a job, can reveal something that has been hidden for decades. And it's worth stating that neither of these teams were actually like actively looking for another planet around Beta Pic. They were trying to study Beta Pictoris b, the first planet in orbit around the star, the bright dot in these images. Now, Gibbs and collaborators also managed to split the reflected light from the planet and take a spectrum using JWST, where they split the light into its rainbow and you get a trace of how much light each colour or wavelength of you receive. That can tell us what the atmosphere of a planet is made of, because specific molecules kind of leave fingerprints on the light at really specific wavelengths. So you can see that Beta Pic d, this new planet that's been discovered, has features of methane, water and carbon dioxide. Don't get too excited though, this is a gas giant world like Jupiter and not a rocky planet. So Gibbs and collaborators estimate a mass of around 2 to 4 Jupiters worth, whereas Sutcliffe estimates 2.4 Jupiter masses, which would make it one of the lowest mass exoplanets that we've managed to image from the ground, this time using VLT. Which is really exciting considering that we've got the extremely large telescope under construction now too, with a mirror 39 meters across. Compare that to VLT's 8.2 meters across. Because the bigger the telescope mirror, the more light you can collect and the fainter the objects you can see. So if Beta Pic d has been hidden for so long, despite how well studied this system is, I can only imagine the number of planets that ELT is going to be able to find that have so far been hidden to us when it comes online at the end of the 2020s. All right, time for our second exciting scientific discovery now, and this one comes from ESA's Euclid Space Telescope, which if you've seen my previous videos all about Euclid, you'll know Euclid is mapping out the positions and distances of galaxies across the sky to make the most detailed 3D map of the universe ever made. And during that map making, Yang and collaborators discovered 31 distant quasars, including not one, but 2 quasars that have broken the record for the most distant quasars ever found. So a quasar is a fancy word for a growing supermassive black hole. A region of space so dense that nothing can escape, not even light. And when material gets too close, it gets drawn into a spinning disk moving so fast because of that strong gravity that the material starts to glow. And it can glow so bright that it can outshine the entire galaxy of stars that the supermassive black hole is at the center of. Especially when that galaxy is very distant, often the only thing we can see is the bright point of light from the material around the black hole. I always think it's crazy that technically black holes are some of the brightest objects in the entire universe. It just doesn't feel like that should be a thing, right? I talk about this more in my book, A Brief History of Black Holes. If you want to check that out, it's linked below. I also narrated the audiobook. But back to these 2 distant quasars from Yang and collaborators. They're not just distant, they're also young. We see them as they were billions of years ago because light takes time to travel to us through the universe. So the 2 most distant that have been discovered are just over 13 billion light years away. That means the light has been traveling for just over 13 billion years through the universe until it gets to us. And so we're seeing them as they were when the universe was just 670 million years old, smashing the previous record by around about 15 million years. And discoveries like this are really important for our understanding of how our universe has evolved to become what it is today. So asking questions like how fast do black holes grow, or is there a limit to how fast black holes can grow, or what came first, the supermassive black hole or the galaxy of stars that it's in the center of. It's kind of like the ultimate astrophysics version of the chicken or the egg question. All of this ties together. And this discovery, from just the initial part of the Euclid survey, like only a fraction of the eventual data we'll have covering the sky, just makes me even more excited for what Euclid will find. And our final discovery of the 3 comes from the trusty Hubble Space Telescope. And it's another black hole related discovery, not of the supermassive black hole variety this time, but instead what's been found is a stellar mass black hole. The kind that's formed when stars run out of fuel and die in a supernova, leaving behind their core, which collapses under its own gravity down until it becomes so dense that not even light can escape, and it becomes a black hole. So where you have a lot of supernova going off, you should then have a lot of black holes forming. And where do you find lots of supernova? You find them where there's lots of stars. In places like this, big star clusters where lots of stars have all formed together at the same time in a big burst from the same cloud of gas. And the biggest of those clusters in the Milky Way is known as Omega Centauri. It's around 17,500 light years away. It contains roughly 10 million stars, weighing in at 4 million times heavier than the Sun. And all of those stars fit in a region just 150 light years across. If you have a telescope, see if you can spot Omega Centauri in the sky for yourself. It's in Centaurus, which is not far from the famous Southern Cross constellation. Now, when stars form like this, like all together in one big burst from the same cloud of gas, you get a really predictable spread of the different masses or types of stars that form, with lots of smaller red dwarf stars forming and then a big tail to heavier stars. The smallest stars live the longest because they go through their fuel at a slower rate, living for tens of billions of years, whereas the heaviest stars live fast and die young in a few 100,000 years. And it's those heaviest stars that when they go supernova leave behind a core that is heavy enough to collapse down into a black hole. So, because Omega Centauri is over 12 billion years old, all the heavy stars in it should already have lived, died, gone supernova, and made a black hole. This star cluster should be absolutely teeming with black holes. Have we ever found any though? Nope. And I know what you're thinking, famously, black holes don't give out any light, so surely we wouldn't be able to find them anyway. But we do know they're there because of their strong gravity, which pulls on stuff around them. And if they're growing, taking in material, just like the quasars we were talking about before, they light up like Christmas trees. So we can look for them in orbit around other stars when you see a single star just wobbling around and we see their light get Doppler shifted because of that movement. Or we can look for the X-ray light from the material that's lit up from spiraling around them. And despite many searches of Omega Centauri using these techniques, we've still not found any black holes. And that's made people consider the idea, well, maybe the black holes are actually getting ejected from the star cluster just because it is so dense and you end up with lots of interactions between stars and black holes that act like slingshots. But this month, Whittaker and collaborators announced the discovery of Omega Cat BH-2, a black hole around about 4.5 times heavier than the Sun, orbiting another star in Omega Centauri. And they found it using a really cool technique known as astrometry, where they record the really precise position of stars over many years to track how it's moving. They pulled in data from Hubble going back to 2002 and recent JWST data. And I just want to try and make clear here, like, the precision that you need to do these kind of measurements is so impressive. Like, I'm talking about like fraction of a pixel on the JWST and Hubble detectors. Now, Whittaker and collaborators are doing an extensive search for possible binary star systems in Omega Centauri as part of a bigger project called Omega Cat. But they've published the most obvious one that they found first. Here you can see how the star that they can see is moving, with the purple line showing the orbit that the Whittaker and collaborators have fit the data. One that takes the star 94 years to complete a full loop. The black star shape there shows the center of mass of the orbit. So it shows the thing the star is orbiting around, where there should be an object, but when we look in images, we can't see anything. So Whittaker and collaborators measured how heavy that thing needs to be to make the star move in this way along its orbit and found it's 4.46 times heavier than the Sun. Something that heavy that we can't see can only be a black hole, making this the first stellar mass black hole found in Omega Centauri, and dubbed by Whittaker and collaborators Omega Cat BH-2. Not BH-1, because technically we've already found an intermediate mass black hole 8,000 times heavier than the Sun in Omega Centauri back in 2024. I covered that in a Night Sky News episode at the time that I'll link below if you want to know more, along with a video on why intermediate mass black holes are so controversial still. But the hope is that the discovery of Omega Cat BH-2 will open the floodgates for more discoveries of stellar mass black holes in Omega Centauri and across the Milky Way, either in the Omega Cat of Whittaker and collaborators or in Gaia data that will be released soon, or in the survey of the Milky Way that NASA's Nancy Grace Roman Space Telescope will start very soon when it launches at the end of August 2026. Safe to say that the next few episodes of Night Sky News are going to have a lot of Roman content in it as we build up towards that launch, so make sure you're subscribed so you don't miss out. And in the meantime, you can check out my previous video on why you should believe the hype for the Roman Space Telescope. All right, that's it for Night Sky News for this month. As always, make sure you catch The Sky at Night on the BBC on the 10th of August to catch yours truly presenting. And if you snap any pictures of the night sky, the eclipse, the Perseids Meteor Shower, or you see any space news stories that you want me to explain in a future Night Sky News episode, then send them my way over on social media because I would always love to see them. But until next time, everybody, happy stargazing. All right, time for our second sky. Ugh. Second exciting. Second exciting. Ugh. Astrometry. I always think it's astrometry, but it's astrometry. You know, it's one of those things that like, I think I know it, but I should check because people will be like, oh, really? And I'm just like, well, space is hard, words are harder, guys. It's like 27 degrees in Derbyshire. What is going on with the world? I'm also trying very hard to avoid the big cowpats that you can't see around here, but this was the one part of shade. It's so hot in here, you've probably been able to see the temperature change. I don't know if anyone's noticed, but I've got a thermometer now back here. One of those Galileo thermometers. I had one when I was a kid, and when I saw it, I was like, oh my God, I want one again. But you can probably tell that the little things started up high and have all dropped down. So it is now warmer than 26 degrees Celsius in this room. Yay!